Do you know that AI cars are now being tested in some of the hottest places on Earth? Deserts where normal vehicles would fail within hours? Welcome to NeuroDriveAiReels. Subscribe and join the ride. When you think of the desert, you imagine an unforgiving world, endless dunes, scorching heat, sand that cuts into machinery like glass. These are not the kinds of places we expect cutting-edge cars to thrive. But the world of mobility is shifting. AI cars, electric, sensor-driven, and self-regulating, are now being pushed into deserts to prove one thing: survival under the harshest conditions. Why? Because the desert is nature's ultimate stress test. If a machine can live here, it can live anywhere. Imagine a sleek AI hypercar gliding over desert highways while the air itself seems to shimmer from heat. Its vents flare open automatically, sensors track every fluctuation of temperature, and holographic warnings pop into the cockpit before the human eye even notices danger. This is the new frontier, deserts turning into laboratories for AI mobility. The first challenge of desert driving is not the sand, not even the storms. It's the heat. Engines seize, tires burst, batteries overheat. AI cars have turned this challenge into a science experiment. Inside their frames are liquid cooling loops, pulsing like veins in a body. These loops don't just react when things get hot, they predict heat before it happens. Cameras and thermal sensors scan the road ahead, recognizing how the asphalt surface is heating in real time. If a hotter zone is detected, the car prepares, shifting cooling flow, reducing power draw, even adjusting the shade of its smart glass roof to block radiation. Then there are AI-regulated heat shields. Think of them like scales of armor across the car's body, which can reflect sunlight and dissipate heat in patterns that keep the battery and electronics stable. Traditional cars burn out here. AI cars adapt, making every kilometer a battle against physics that they're programmed to win. But the desert has more than heat. It has storms. Sandstorms arrive without warning, erasing the horizon in minutes. Visibility drops to zero, dust suffocates air filters, and driving becomes suicide for most vehicles. For AI cars, sandstorms are a proving ground. Instead of headlights and guesswork, they rely on LiDAR, radar, and infrared mapping. Dust clouds scatter visible light, but LiDAR beams cut through the storm like invisible eyes. The car doesn't just see the storm, it maps every swirl of particles, every dune being reshaped by the wind. Holograms inside the cockpit project a safe corridor in glowing blue. Instead of panic, the driver sees certainty. In convoys, AI cars communicate like migrating. Do you know classic cars are now being rebuilt with AI brains? Imagine a 1969 muscle car, chrome shining, engine roaring. Traditionally, it relied entirely on human skill, intuition, and experience. But today, engineers are taking these classics and integrating advanced AI systems directly into their architecture. This is not just an upgrade, it's a complete transformation. The process starts by scanning every mechanical system: engine, transmission, suspension, and braking. Using high-resolution 3D mapping, the AI can understand the vehicle's dynamics at a level no human mechanic could. Then, a neural network is trained on the car's performance, learning how the machine responds under stress, speed, and road conditions. Next comes the interface. Analog dials are replaced by holographic dashboards that project real-time diagnostics, predictive safety warnings, and autonomous control options. The AI integrates sensors, cameras, and LiDAR to monitor the environment, pedestrian movement, traffic, road friction, transforming the classic into a semi-autonomous hypercar. Do you know? Some of these AI classics retain their manual control for purists while offering optional AI-guided driving. You can still feel the thrill of steering and shifting, but now, safety nets are always active. Lane keeping, collision avoidance, predictive braking, and adaptive power management. In the garage, Engineers use simulation to rehearse transformations digitally before applying them to real vehicles. They model thousands of scenarios, rainy nights, heavy traffic, sharp curves, all integrated into the AI's learning algorithm. The result is a car that remembers every street and adapts in real time. This mechanical-to-AI fusion doesn't only improve performance, it preserves history while embracing the future. The classic silhouette remains, the chrome, the curves, the distinctive roar, but underneath, intelligence drives every decision. The car is no longer just a machine, it's a partner, a co-pilot with reflexes faster than human reaction times. Imagine entering a transformed AI hypercar on a neon-lit city street. The analog dashboard flickers, then blooms into holographic controls. Sensors scan the environment, while AI algorithms predict traffic flow, adjust suspension, and optimize battery or fuel efficiency. Even manual inputs are assisted subtly, so the car responds with perfect balance. Engineers are also exploring emotional AI. By reading driving patterns and road conditions, the system can adapt responsiveness based on your style, providing comfort for relaxed drives or enhanced control during spirited maneuvers. It's a synergy of man, machine, and intelligence. But there are questions. Should AI be added to? Do you know that urban flooding and extreme weather could paralyze modern cities? But AI hypercars are changing the game. In rain-soaked cyberpunk streets, these vehicles operate with precision far beyond human capability. LiDAR, radar, and predictive neural networks combine to create a constantly updated virtual map. Vehicles communicate in real time, forming a living swarm that adapts to floods, storms, and urban chaos. Imagine a city where storms no longer halt movement. Neon reflections shimmer on puddles as AI hypercars glide past, calculating every hazard. Cockpit HUDs display predictive overlays, flood sensors, tire grip, and pedestrian paths. In extreme weather, milliseconds matter. AI continuously adjusts acceleration, braking, and steering to prevent skidding or collisions. Dynamic lane formation prevents collisions. AI cars move in synchronized swarms, projecting holographic safety zones. Emergency vehicles are given priority. AI forms protective corridors automatically. Drones hover overhead, relaying real-time data to vehicles. The cars and drones operate as a coordinated ecosystem, transforming urban mobility into a proactive intelligence system. Simulation labs train these vehicles on thousands of scenarios. Flash floods, heavy storms, traffic congestion, sudden obstacles. AI learns from every scenario, anticipating and responding faster than human reaction times. Even under chaotic urban conditions, AI hypercars optimize energy use. Regenerative braking captures energy. Predictive routing reduces unnecessary acceleration. The cockpit becomes cinematic. Neon reflections ripple across rain-streaked glass. Dashboards project predictive graphics. Semi-autonomous controls assist subtle driver inputs. On a citywide scale, AI hypercars operate collectively. Aerial views show neon-lit highways filled with glowing vehicles in synchronized patterns. Holographic flood maps overlay streets, showing traffic flow and hazards in real time. Emergency scenarios highlight AI potential. Stranded pedestrians are detected, vehicles form protective corridors, drones provide aerial assessment, and traffic reroutes dynamically. Storms intensify, wind gusts, rising floodwaters, but predictive algorithms continuously calculate optimal speed, tire grip, and suspension. Each decision is precise and instantaneous. AI anticipates both vehicle behavior and environmental changes, including pedestrian movement and flood patterns. Cities with AI hypercars become resilient ecosystems, with traffic flowing safely even during disasters. The question remains, would you trust an AI car to navigate a flooded, storm-ridden city? Could you rely on predictive intelligence to safeguard your life, passengers and time. Cinematic desert solar highway at dusk. Sweeping wide aerials capture endless golden dunes shimmering under the fading sunlight, stretching in every direction. The horizon blazes with gradients of deep orange, crimson, and violet, while futuristic neon energy veins embedded in the asphalt pulse steadily, glowing like arteries carrying life across the barren desert. The camera dives lower. Fleets of hypercars glide across the highway in synchronized harmony, their aerodynamic silhouettes polished in silver and black, accented with sharp neon trims. From above, the convoy appears like a river of light weaving across the sands. Ground-level slow motion follows each wheel as it locks into alignment with glowing tracks beneath. Energy arcs leap upward like captured lightning, flowing invisibly into the chassis. Atmospheric dust rises with every burst of speed, swirling around the cars, catching the neon glow, forming halos of electric mist. Holographic overlays shimmer above the highway. Live dashboards floating in the air, displaying efficiency rates, energy flow, predictive road scans, and futuristic traffic signals glowing in teal and magenta. Narration opens with mystery. Do you know some hypercars can charge themselves while driving on solar roads? Imagine never having to stop at a charging station because the road beneath your wheels becomes an endless stream of power. These futuristic highways are engineered with solar panels fused into their foundation, channeling clean energy wirelessly to vehicles in constant motion. Visual escalation. Wide cinematic sweeps show roads carving through diverse desert terrains, spirals through canyon walls glowing blue, elevated solar bridges over shimmering salt flats, and vast straightaways extending infinitely toward glowing horizons. Rest stations rise from the sands like glass oases, domes of crystalline solar cells surrounded by AI drone pads. Tall holographic towers beam iridescent data into the sky, syncing with cars hundreds of kilometers away. Narration continues. In this future, you don't pull over to recharge. Your journey itself becomes the source of power. The desert, once dismissed as empty, transforms into the world's greatest laboratory of innovation. Endless sunlight, endless energy, endless motion. Cockpit close-ups. Drivers sit enveloped in transparent dashboards that double as panoramic HUDs. Energy streams animate live across the windshield, tracing pulsing lines between road and car. Efficiency charts ripple like heartbeats. Glowing blue data orbits the driver, projecting range estimates and AI forecasts in real time. If your country had solar highways, would you trust your car to charge itself while driving? Do you know that some of the AI technology guiding self-driving cars on Earth is inspired by NASA research for space travel? Let's explore why. NASA has spent decades teaching computers to navigate the Moon, Mars, and satellites in orbit. These systems calculate trajectories, avoid obstacles, and make autonomous decisions in environments where humans cannot physically intervene. Engineers realized that similar principles could improve terrestrial autonomous driving. On Earth, roads are far less predictable than space. Potholes, debris, erratic drivers, sudden weather changes all demand a predictive and adaptive system. NASA-inspired AI brings the precision of orbital mechanics to ground vehicles. Neural networks are trained using simulation data originally designed for Mars rovers, adjusting for friction, slope, and sensor input variability on Earth roads. Imagine driving at night in a neon-lit city while torrential rain floods the streets. The AI predicts hazards ahead, recalculates paths in milliseconds, and communicates with other vehicles through cloud-based vehicle-to-vehicle networks. Every decision is informed by advanced simulation algorithms that once guided interplanetary missions. Sensors inspired by satellite imaging monitor urban landscapes. Cameras and LiDAR feed into algorithms that have already learned to distinguish between terrain anomalies in space, now applied to curbs, street debris, or sudden road changes. The AI doesn't just see what's in front of it, it anticipates what will happen next. Do you know? Some experimental self-driving cars now integrate orbital-grade predictive models, providing millisecond foresight into potential collisions. The system essentially plays out multiple future paths at lightning speed, then selects the safest trajectory. It's like having a GPS fused with a space mission control center. These technologies also improve energy efficiency. By anticipating stoplights, curves, and traffic density, AI can optimize acceleration and braking, conserving battery power in electric vehicles. This isn't only about safety, it's about efficiency, sustainability, and smarter urban mobility. But there's more. Space-inspired AI allows cars to make ethical decisions under uncertainty. In simulation labs, engineers test scenarios derived from orbital problem-solving, sudden obstacle appearance, pedestrians crossing unexpectedly, or split-second emergency maneuvers. Neural networks weigh options, prioritize outcomes, and learn from synthetic trials that humans could never replicate manually. Picture a future commute, your AI car gliding silently under neon city lights, every movement calculated by algorithms inspired by satellites orbiting thousands of kilometers. Do you know that most AI cars don't just train on perfect sunny days? They actually learn from the worst storms, the darkest nights, and the hardest roads? Let's step into the rain. Picture a cyberpunk street where neon blurs on puddles, wipers swish, and fog clings to glass. For humans, this is where accidents multiply. But for AI systems, this is the classroom. Why? Because teaching a machine to drive well in bad conditions makes it safer in all conditions. Engineers feed cars not only real-world storm footage, but simulated worlds where rain is exaggerated, where glare blinds sensors, and where pedestrians appear suddenly under umbrellas. Each frame becomes a lesson. If the road shines too bright, slow. If a figure is half hidden in shadow, anticipate movement. In labs from Detroit to Tokyo, engineers run cars through synthetic bad weather generators. Picture a server hall where GPUs churn out millions of rain scenarios, droplets falling at different angles, glare bouncing differently off neon. The AI doesn't get frustrated. It just learns. Slowly, statistically, it builds patterns of safety where chaos lives. Now, let's talk about radar and LiDAR. Rain scatters signals. Fog bends light. A human driver squints, but AI blends sensors. Camera says, blurred outline, maybe person. Radar says, solid object, 30 meters. Together, they cross-check, creating certainty from uncertainty. Do you know? Some companies actually spray fake rain on test tracks just to break their own AI. The goal is not perfection, it's resilience. Because resilience, not perfection, saves lives. Let's imagine the future. You step into an AI taxi at midnight, thunder above, sheets of rain falling. The AI doesn't panic. It recalls billions of rainy miles. It slows where it must, accelerates where safe, and navigates puddles like it's done it 1,000 times before, because in training, it has. This isn't just safety, it's trust. Trust built through invisible storms, the AI has already survived before you ever sat inside. And there's another side. Ethics. In slippery conditions, who does the AI protect first? You, the passenger, or the pedestrian that might run across? In labs, those decisions are coded. So every rainy street becomes more than physics. It's philosophy on wheels. Closing questions. Would you trust a machine to drive you in a storm if it's been trained on more rain than any human ever could experience? Should governments mandate storm training before a car gets approved? Should AI always prioritize life outside the car over life inside? Imagine a world where fewer families lose someone in a rainy crash because the driver wasn't human. It was an AI that never blinked. Do you know that the sky above our cities is becoming an extra lane? On 30th of August 2025, NeuroDriveAiReels asks, do you know how flying cars and air taxis are being integrated into busy city airspace? This isn't science fiction. It's regulated air corridors, air traffic-grade autonomy, and the same safety principles that keep jets aloft, squeezed into urban skies. The first challenge is predictability. Ground traffic follows lanes. Air traffic must do the same. Cities testing air taxis build skylanes, vertically stacked corridors controlled by a central traffic manager. Think of them as highways in the sky, painted in sensor telemetry rather than asphalt. This architecture allows hundreds of small VTOLs to operate without chaos. Next is sensing. In the ground world, LiDAR, radar, and cameras suffice. In the sky, vehicles combine those sensors with ADS-B, like systems for position sharing, and redundant GNSS solutions to deal with urban canyon GPS errors. The result is a multimodal situational awareness that treats birds, weather, drones, and tall buildings as equally important hazards. Another, do you know? Japan and several other countries have moved from demos to regulated pilot corridors. These pilots gather real human behaviors. How do people queue to board an air taxi? How do city services handle emergency landings? That data feeds AI models that must think like an air traffic controller and a taxi driver at once. Integration also raises the human factor. People need legible signals, approach lights, landing pads with dynamic markers, audible announcements. Urban residents need reassurance that a VTOL overhead is predictable, not random. So designers build invisible intent, approaching lights that flash in patterns to indicate a vehicle's next action, descend, hover, or clear the pad. These UX signals reduce startle response and build public trust. Then there's energy. VTOLs are heavy on power. Charging has moved beyond the depot model. Some cities use rapid swap battery hubs, others harness centralized high-power tether stations near landing pads. On longer routes, hybrid models combine small combustion or fuel cell range extenders with electric lift motors. The balance between noise, emissions, and range is an active design trade-off. Safety comes first. Autonomous deconfliction systems allow VTOLs to negotiate right-of-way in milliseconds, using both local sensors and shared telemetry. Emergency descent paths and automatic safe landing protocols are enforced by software, and regulators require multi-layered redundancy. If one motor fails, the craft can glide to a planned safe zone. These are the same reliability principles that have protected commercial aviation for decades. Ultra-cinematic neon cyberpunk city at dusk, the sky painted with deep indigos and streaks of electric magenta. Towering skyscrapers with glass facades glowing with holographic ads stretch into the horizon. Glowing highways snake through the city like veins of light, packed with AI-powered hypercars, each moving with precision and silent elegance. Streets reflect a mix of neon pinks, blues, and purples from the ambient city glow, and a fine drizzle creates reflective puddles on the road, catching the light of every passing vehicle. Lens flares bounce off chrome edges and holographic dashboards, adding surreal bursts of color, making the city feel alive, almost sentient. Mechanical muscle cars, iconic for raw automotive power, roar down the avenues. Suddenly, in a dazzling display of technological transformation, metallic panels slide, wheels reconfigure, and holographic circuits cascade across their bodies. They evolve into futuristic AI hypercars, sleek and intelligent, exuding a sense of speed and awareness once impossible. The transformation is captured in slow motion, every spark, lens flare, and cascading holographic line highlighted as if the car itself is breathing and thinking. Cinematic camera movements sweep around these vehicles. Aerial tracking shots follow them from above glowing highways, swooping between skyscrapers, capturing the juxtaposition of old-world muscle and futuristic intelligence. Close-up cockpit shots reveal holographic dashboards lighting up with real-time complex data, speed, battery levels, AI learning patterns, environmental scanning, immersing the viewer in a world where cars are active participants in the city's pulse. Flying drones hover above, their red navigation lights cutting through misty neon haze. Some carry parcels, others scan streets, projecting interactive holographic AR billboards advertising futuristic products. Among them, the NeuroDrive holographic text pulses across the skyline in cyan and magenta, announcing the city's technological heartbeat. Rain softly pelts the camera lens as drones weave between skyscrapers, reflections shimmering like tiny constellations on wet glass. Transitioning from city streets to solar desert highways, the scene expands to vast, open landscapes. Golden sands stretch endlessly under a twilight sky, while sleek AI hypercars race along solar-charged highways. Embedded panels absorb sunlight and convert it into energy, powering vehicles at breathtaking speeds. Holographic cockpit readouts display energy intake in real time, showing how these cars can self-charge while driving, eliminating traditional refueling stops. Roads shimmer with neon reflections as cars dash across deserts, emphasizing harmony between technology and nature. Do you know your future car could be the next soldier in a global cyber war? While we imagine cars as engines, wheels, and speed, today's AI cars are digital fortresses. Each autonomous vehicle is not just connected, it is constantly communicating with satellites, road systems, and millions of other machines. This makes them powerful, but also vulnerable. Hackers know this. Imagine someone seizing control of an AI car, not through the steering wheel, but through code. "I'm in. I've breached the firewall," Hacker 1 said excitedly. "Now shut down the engine," Hacker 2 commanded. They could shut down highways, cause traffic chaos, or even use vehicles as moving weapons. That's why AI cybersecurity has become as important as brakes and seatbelts. Inside the cockpit, it's no longer just a dashboard, it's a battlefield. Algorithms are scanning for intrusions, firewalls evolve in real time, and data shields deploy instantly when suspicious activity is detected. Intrusion detected. "Deploying countermeasures," the AI voice announced in a robotic and urgent tone. Cars fight back by learning from each attempted hack, growing smarter with every digital encounter. Think of it as a silent war happening while you drive, hackers versus AI guardians. In some cases, cars even link together, forming secure networks where vehicles defend each other like soldiers in a convoy. "Network attack detected. Initiating coordinated defense," the AI voice announced, robotic and urgent. The question is, will the future of driving be decided on the road or in cyberspace? What do you think? Should cars be treated like weapons of cybersecurity, or is that going too far? Do you know your everyday life depends on invisible highways powered by AI? From the coffee you drink in the morning to the phone in your pocket, every item has traveled across the world through a vast, interconnected supply chain. For decades, these systems relied almost entirely on human oversight, manual planning, human drivers, and human coordination. Every delay, every miscommunication, every storm or traffic jam could ripple across continents, causing shortages, price spikes, or worse. But today, AI is changing everything, and cars, trucks, and autonomous vehicles are at the center of this revolution. AI trucks don't sleep. They don't take breaks. They move day and night, guided by predictive algorithms that anticipate road conditions, weather, and port congestion. If a storm shuts down a seaport in Singapore, an AI system instantly calculates alternative routes through Malaysia or Indonesia. If a bridge collapses in Europe, convoys reroute without a second's hesitation. These are not just hypothetical scenarios. This is happening now. It's not only speed and efficiency. AI supply chains are becoming a new form of global defense. In a world where disruptions can delay medicine, food, or essential electronics, AI ensures stability. Cars and trucks equipped with smart sensors guard cargo, scanning for tampering and alerting control centers to any irregularities. Drones fly overhead, analyzing packages, recording security data, and even guiding trucks around potential hazards. AI systems communicate with each other, coordinating convoys like a synchronized ballet of machines. Imagine glowing convoys crossing continents, night highways lit by neon headlights, moving like living streams of data. Ports where robotic cranes talk directly to ships, lifting containers in perfect rhythm. Warehouses that organize themselves, sorting billions of packages with robotic arms and forklifts, working in seamless harmony. Autonomous cargo ships glide through fog and icy waters, docking with AI precision. Every element is connected, optimized, and monitored. AI doesn't just follow pre-programmed routes, it predicts them. Using data from weather satellites, traffic cameras, and satellite imagery, AI reroutes shipments before a delay even occurs. It reduces waste, prevents spoilage, and ensures that global supply chains operate at near-perfect efficiency. What used to take hours of human oversight now happens in milliseconds. And yet, this level of control raises profound questions. Who designs these AI networks? Who ensures their ethical operation? If AI is entrusted with the lifelines of global trade, what happens if it makes a mistake, or if someone with malicious intent tries to interfere? From deserts to neon cities, the journey of AI cars continues. Witness transformations from classic machines to intelligent hypercars, mastering every challenge on Earth and beyond. Flying cars, smart highways, and futuristic streets, the future is already here. AI cars are learning, adapting, and evolving every second of every drive. The road ahead is infinite. Subscribe to ride with us.